Hey man, I got something hella special for y'all today that's finna blow y'all minds. I know y'all been asking me to put out more gang videos and best believe I'm finna continue dropping those. But today I got a special guest that's about to make y'all heads spin. Meet Hitch, my plug for that genius level. Cray Cray, who also happens to be a scientist from Switzerland. You know them people over there talking, pondering, and experimenting about some wild ish. I told y'all I'm connected. The homie's about to drop some knowledge on y'all about how AI finna take over skilled trades. You heard that right. Not coding jobs, not graphic designers. I'm talking the trades, carpentry, plumbing, mechanics. So put on your chinchilla and get comfy, cause this finna be a banger. Over to you, Dr. Hitch.
Thanks, man. Let's get right into it. The accelerating pace of artificial intelligence development points to a future where artificial general intelligence (AGI) will profoundly reshape the labor market, particularly within skilled trades, far sooner than many anticipate. By 2027, the traditional landscape of these professions is projected to undergo a fundamental and irreversible transformation. This isn't a speculative sci-fi prediction, but a logical extension of current technological trajectories and a direct consequence of AI's exponential growth. Just months ago, AI-generated images were rudimentary, often distorted, and required significant processing time. Today, the same technology effortlessly produces photorealistic masterpieces in mere seconds, a testament to its dramatic and accelerating improvement. This rapid advancement isn't an isolated phenomenon. It's a consistent pattern across the various AI domains. Beyond image generation, we've witnessed breakthroughs in sophisticated text generation, where large language models produce coherent and contextually relevant narratives, evolving from basic sentence structures to complex prose in a remarkably short period. Similarly, AI's capability in code generation has advanced from rudimentary script snippets to writing functional, optimized code from natural language prompts, accelerating software development cycles exponentially. In the realm of scientific research and drug discovery, AI is compressing processes that once spanned decades into mere months or even weeks, rapidly analyzing vast datasets, identifying novel compounds, and simulating complex biological interactions. These aren't just incremental improvements, they represent a fundamental shift in the pace of innovation, underscoring the exponential nature of AI's progress. As noted by leading researchers at institutions like Google DeepMind, the speed of these advancements isn't decelerating, it's intensifying, consistently outstripping even the most optimistic forecasts. We are no longer observing a gradual technological evolution, but are instead standing on the precipice of a revolution driven by artificial general intelligence. Once AGI achieves human-level cognitive capabilities, its ability to think, learn, and create will far exceed human capacities, ushering in an era of unprecedented engineering prowess and economic restructuring. The arrival of AGI isn't a distant, abstract concept, but a near-term economic reality that will directly impact the skilled trades. But let's be absolutely clear about what we mean by artificial general intelligence, or AGI. This isn't merely the highly sophisticated AI we see today, like ChatGPT or advanced image generators, which, while powerful, are still considered narrow AI, excelling at specific tasks but lacking generalized understanding. AGI represents a far more profound leap. It's an artificial intelligence that possesses the cognitive abilities of a human being across a broad range of tasks, capable of understanding, learning, and applying intelligence to any intellectual problem that a human can. This includes abstract reasoning, problem solving in novel situations, common sense understanding, creativity, and the ability to learn from experience and adapt to new environments without explicit pre-programming. It's the point where a machine can learn how to learn almost anything, synthesizing information from diverse sources and applying it flexibly, much like a human mind. This comprehensive, adaptable intelligence is the key differentiator, marking the transition from powerful tools to true artificial minds. The question then becomes, how soon can we realistically expect such a transformative technology to arrive? Our analysis suggests that AGI could become a reality by 2026. This aggressive timeline isn't based on speculative optimism, but on the compounding factors of exponential AI growth, unprecedented financial investment, and a self-improving development cycle. according to research from organizations like Arca Invest, which meticulously tracks technological adoption curves. AI capabilities are progressing at a rate far exceeding earlier forecasts, significantly outperforming Metcalfe's law in terms of value creation and technological acceleration. Furthermore, scientists like Dr. Ray Kurzweil, renowned for his accurate predictions on technological progress, have consistently pointed to the exponential increase in computational power and algorithmic efficiency as a clear indicator of AGI's rapid approach, even suggesting timelines that align closely with our 2026 projection. The sheer unprecedented volume of vested interest and capital flowing from major tech companies, Google, Microsoft, Amazon, OpenAI, is acting as an accelerant like never before. These multi-billion-dollar investments are fueling intense research, enabling the recruitment of the world's brightest minds, and providing access to unparalleled computational resources, driving breakthroughs at an astonishing pace. This is no longer just academic curiosity. It's a fiercely competitive race to develop the most powerful AI, creating a feedback loop where resources and talent are continuously poured into accelerating development. If we indeed reach AGI by 2026, the subsequent step will be almost instantaneous. This super intelligent entity will then begin designing and overseeing the manufacturing of highly optimized, purpose-built robots, engineered specifically to replace and fundamentally outperform human-skilled labor across virtually every trade. This means the window for preparation is narrowing with incredible speed. Many individuals currently working in skilled trades, from electricians and plumbers to welders and HVAC technicians, often hold a deeply ingrained, yet increasingly precarious belief: my job is safe, my work demands nuance, fine motor skills, and complex problem solving that no robot could ever replicate, especially not within a mere 2-year timeframe. This perspective often stems from observing the current generation of industrial robots, which, while impressive in controlled environments, still appear clumsy and dysfunctional when attempting tasks requiring high dexterity or adaptability in unstructured settings. One might point to a video of a robot struggling to open a door or maintain balance on uneven terrain and dismiss the threat, confidently asserting that tasks like carpentry, with their intricate joinery and precise measurements, are simply beyond the reach of automated systems. This viewpoint is understandable if one is solely fixated on the limitations of contemporary robotics. However, it critically overlooks the impending paradigm shift that AGI represents. The clumsiness and lack of common sense exhibited by today's robots are characteristic of pre-AGI systems. Once AGI is achieved, these limitations, which currently seem insurmountable, will be rapidly overcome, transforming the capabilities of robotic hardware in ways that are difficult to fathom from our current vantage point. The transition from specialized, narrow AI to a truly general artificial intelligence will unlock an era of superhuman engineering and design, rendering previous robotic deficiencies obsolete. The first critical argument that dismantles the complacency of skilled trades lies in the sheer unbridled power of AGE. Once AGI arrives, engineering progress becomes superhuman. Imagine a mind that doesn't just think, but designs, problem solves, and innovates at speeds millions of times greater than the collective intelligence of all human engineers combined. An AGI wouldn't engage in laborious trial and error experimentation. Instead, as Dr. Stuart Russell at UC Berkeley, a prominent AI researcher, has posited, it could execute trillions of simulations within minutes, evaluating every conceivable robot design mathematically and flawlessly, long before a single physical prototype is built. This capability transcends mere efficiency. It allows AGI to discover entirely new mechanical principles, material properties, and design paradigms that human engineers, limited by their cognitive biases, accumulate knowledge and linear thought processes, have never even considered. AGI doesn't suffer from fatigue, doesn't get intellectually stuck, and isn't constrained by legacy methods or preconceived notions. It operates with a boundless capacity for optimization, continually refining and perfecting designs without human limitations. This leads to a stark and undeniable conclusion. AGI would systematically resolve all major bottlenecks currently hindering robotics: dexterity, balance, grip control, sophisticated locomotion, and advanced material science. Not over decades, but potentially within days. The perceived clunkiness of current robots is merely a pre-AGI engineering problem. Once AGI commands the design process, these become trivial challenges, rapidly yielding to elegant and hyper-efficient solutions. Building on this superhuman engineering capability, our second argument highlights AGI's capacity for extreme specialization. AGI can optimize robot bodies for each trade instantly. Human beings are remarkable generalists. Our physiology allows us to perform a vast array of tasks, from intricate surgery to heavy construction. However, this versatility comes at the cost of optimal specialization for any single task. Our bodies are inherently compromises. In contrast, robots, particularly when designed by an AGI, can be purpose-built specialists. An AGI, with its unparalleled design capabilities, could conceive and perfect dozens, even hundreds, of distinct robotic bodies, each meticulously engineered for a specific trade, or even a specific task within a trade. Consider a plumber robot, for instance. AGI could design a slim, multi-jointed automaton capable of navigating the impossibly tight spaces behind walls, beneath sinks, or deep within pipe networks, performing delicate repairs with tools integrated directly into its specialized manipulators for heavy construction. Imagine a robot that can effortlessly lift 200-pound components, designed with perfect balance and strength distribution unmatched by any human. Picture a carpentry robot executing micron precision cuts and complex joinery, its limbs guided by algorithms that ensure flawless replication of architectural designs every single time. Furthermore, AGI could design miniature, highly agile micro robots capable of traversing the interiors of pipes, diagnosing hairline cracks, blockages, or corrosion, and even performing localized repairs autonomously. For tasks involving heights and difficult access, specialized drone robots could inspect, measure, and even install components on roofs, rafters, and high-rise structures with unparalleled speed and safety. Humans simply cannot achieve this level of parallel, hyper-specialized physical optimization across an entire workforce. The conclusion is clear. AGI wouldn't just replace human tradespeople, it would radically outperform them, fielding a diversified army of purpose-built machines whose physical capabilities humans simply cannot match. Your natural human limitations, once an advantage in versatility, would become an insurmountable disadvantage against such specialized robotic perfection. The third compelling argument delves into a deeper form of disruption. AGI can redesign entire trades from scratch. This isn't merely about replacing a human with a robot to perform an existing job. It's about fundamentally re-engineering the very nature of the work itself. An AGI, with its ability to understand complex systems at a foundational level, wouldn't just build better robots, it would reconceptualize the entire process and infrastructure of a trade. As observed by visionaries like Kai-Fu Lee, a prominent venture capitalist and AI expert, AGI would approach a system like plumbing, for example, and optimize it from its core principles. It might discover and design revolutionary plumbing materials that are self-cleaning, self-healing, or impervious to corrosion and calcification. It could engineer entirely new drain geometries that inherently prevent clogs, making traditional snaking and drain repair obsolete. Imagine modular fixtures for kitchens and bathrooms that are designed for effortless, automated installation and feature integrated self-diagnosing systems, alerting and central AI to a potential issue before a human even notices a drip, and in some cases, even performing micro repairs autonomously. For electrical systems, an HVAC AGI could design smarter layouts, predictive maintenance protocols, and fail-safe components that eliminate common human errors and system failures entirely. The very complexity and inherent vulnerabilities that currently necessitate skilled human intervention would be designed out of the system. Thus, the job itself becomes inherently simpler, more robust, and critically, far easier to automate. The conclusion here is profound. Human tradespeople will become obsolete, not only because robots can execute the current work, but because AGI fundamentally alters the entire operational system to be inherently robot-friendly, minimizing complexity, maximizing intrinsic reliability, and reducing the need for human skilled labor altogether. The traditional job description simply won't exist in its current form. Furthermore, our fourth argument highlights an insurmountable advantage robots will possess. AGI eliminates the learning curve. The mastery of any skilled trade is a testament to years, often decades, of dedicated apprenticeship, hands-on experience, rigorous certification, and the accumulation of hard-won practical knowledge. This arduous learning process is a point of pride for tradespeople and a cornerstone of their value. However, an AGI-driven robot does not require years. It requires mere moments. According to scientists at OpenAI, advanced AI systems are capable of absorbing, synthesizing, and internalizing vast quantities of information at speeds that utterly dwarf human cognitive capacity. An AGI could instantaneously ingest every plumbing manual, every electrical codebook, millions of hours of installation and repair video footage, and comprehensive 3D models of every known failure mode and successful solution for a particular trade. This isn't just data absorption, it's immediate comprehension and integration. More critically, an AGI could instantly learn new techniques and optimize workflows, not just for a single robot, but simultaneously share these perfected insights and updated protocols to every single robot in its entire operational fleet. Imagine a groundbreaking new welding technique developed by AGI in a simulation. It would be instantly uploaded and mastered by every welding robot globally. If one robot encounters an unprecedented problem and an AGI devises a solution, that solution is immediately disseminated to all other units, preventing the problem from ever occurring again in the fleet. This continuous, universal, and instantaneous learning process means that one improvement, one breakthrough, or one optimization propagates across an entire robot workforce, creating an exponential rate of progress that is utterly impossible for human tradespeople, with their individual learning curves and finite lifespans, to compete with. Your decades of meticulously acquired expertise, which represents immense value today, can be downloaded and surpassed by an AGI-powered robot in the blink of an eye. The traditional learning curve for these advanced automated systems ceases to exist. The fifth argument addresses a common counter-argument regarding scalability. Manufacturing robots isn't the bottleneck anymore. Even if AGI can design revolutionary robots, some might contend, the sheer logistical challenge of manufacturing them in sufficient numbers to replace an entire human workforce within 2 years remains insurmountable. This too is an outdated assumption. Once AGI produces the designs perfectly optimized, error-free, and explicitly engineered for automated mass production, modern manufacturing capabilities are more than capable of scaling up rapidly. We are talking about advanced automated factories leveraging state-of-the-art technologies, computer numerical control, CNC machining, which can produce highly precise components at high volumes, is already extensively automated. Robotic assembly lines, guided by sophisticated AI, can piece together complex machinery with speed and accuracy far beyond human capabilities. High-speed industrial 3D printing, evolving far beyond hobbyist applications, can rapidly churn out intricate and customized parts from a vast array of materials, from advanced polymers to specialized metal alloys. Furthermore, the entire supply chain and logistics of these factories will be managed by AI, optimizing material flow, predicting demand, coordinating production schedules, and ensuring efficient distribution. Autonomous factories, operating with minimal or even no human intervention, are no longer theoretical concepts but increasingly a reality capable of continuous 24/7 operation. The human element in the production process is systematically being removed at every step. The conclusion is unambiguous. The timeline from AGI design to the widespread deployment of robot tradespeople will be compressed dramatically. What once might have taken decades of human-led engineering, prototyping, and factory setup will now be executed in a matter of months or even weeks. The delay between invention and widespread implementation will be almost negligible. Perhaps the most potent driver for the replacement of human trades will be purely economic, as AGI would be cheaper than human labor. Quickly, companies, irrespective of their stated values or corporate social responsibility initiatives, ultimately prioritize their bottom line. The incentive to replace human trades with AGI-driven robots will not merely be strong, it will be overwhelming and, from a business perspective, entirely rational. Consider the myriad costs associated with human labor that simply vanish with robotic replacements. Robots do not suffer injuries on the job, eliminating costly workers' compensation claims, lost productivity due to recovery time, and the significant expenses of maintaining workplace safety regulations tailored for human vulnerabilities. They don't take breaks, don't ask for overtime pay, and don't require the substantial investment in initial training, ongoing professional development, or skill upgrades. Robots do not form unions, do not engage in collective bargaining, and crucially, they do not quit, ensuring a stable and predictable workforce. Furthermore, they perform tasks with perfect consistency, eliminating measurement mistakes, installation errors, and the associated costs of rework and liability that plague human operations. They can operate tirelessly, 24 hours a day, 7 days a week, with unflagging precision and output. As research from institutions like the Massachusetts Institute of Technology has consistently shown, the operational costs of advanced robotics are already on a steep downward trajectory. The initial capital investment in robotic systems, while significant, will be quickly offset by the elimination of ongoing human labor expenses and the gains in efficiency and consistency. The conclusion is stark and simple. The profound cost incentive alone will compel companies, driven by competitive pressures and the pursuit of profitability, to transition from human tradespeople to robotic alternatives as rapidly as technology allows. It is not a matter of loyalty, but of economic inevitability. Our seventh argument addresses a crucial aspect of the safety perception surrounding trades. Trades are not safe once the intelligence barrier is solved. The primary reason skilled trades are currently perceived as largely immune to automation is the historical difficulty robots have faced in replicating human dexterity, common sense, and nuanced physical reasoning. The prevailing belief has been robots simply cannot think like a human. They lack the intuition, adaptability, and problem-solving skills required for complex, unpredictable job site conditions. However, this entire premise collapses with the advent of AGI. If an AGI can understand the intricate physics of the real world with human-level intuition, comprehending forces, material properties, and environmental dynamics, then one of the biggest hurdles disappears. If it can plan complex, multi-step sequences of physical tasks, anticipating consequences and optimizing execution paths, the planning problem is solved. If an AGI can adapt instantaneously to unexpected situations, a broken pipe, a shifting foundation, an unanticipated obstruction, and diagnose problems in real time without predefined programming, then the brain problem that once protected human traits disappears entirely. Moreover, AGI's capabilities extend beyond mere intelligence. They encompass design. If AGI can also design revolutionary robotic components, creating highly dexterous multi-jointed hands with incredible sensitivity, engineering more powerful and energy-efficient motors, integrating advanced sensors that surpass human perception, and constructing more resilient, adaptable, and specialized robotic bodies, then the body problem, the physical limitations of current robots, will also rapidly cease to be a barrier. The conclusion is clear and profoundly unsettling for many. Once AGI crosses the critical threshold of human-level intelligence and applies it to physical design and execution, skilled trades will not only become automatable but will rapidly transition into one of the most automatable sectors. The perceived safety net of human intelligence and physical prowess will be systematically dismantled. Finally, and perhaps most counterintuitively, our eighth argument is that AGI could replace trades faster than any sector because trades are physical, not cognitive. Many assume that highly cognitive white-collar professions, law, medicine, high-level finance, or even politics, will be the first to be comprehensively automated because AI excels at information processing. While AI will indeed profoundly transform these sectors, their replacement by AI-driven systems might face significant delays due to a complex web of existing regulations, deeply entrenched professional organizations, powerful lobbying groups, and societal ethical considerations designed to protect human practitioners. The legal and medical professions, for example, are heavily guarded by licensure, liability laws, and a vast body of regulations that would take years, if not decades, to adapt to a fully automated system. In contrast, skilled trades, while requiring significant expertise, are primarily physical applications of knowledge. They generally operate under fewer, less intricate regulatory barriers, compared to professions requiring high-stakes cognitive judgment and complex ethical frameworks. There are simply fewer legal and societal hurdles to replace a human electrician with a robotic one than there are to replace a human judge with an A. A judge, the physical labor aspect, once a deterrent for automation, becomes an accelerant once robots achieve AG, a level dexterity and reasoning. When the robot problem of physical capability is solved by AGI, the relatively lower regulatory and political barriers surrounding trades will make them exceptionally vulnerable. The conclusion, therefore, is striking. Once AGI achieves mastery over robot dexterity and physical reasoning, skilled trades, perhaps unexpectedly, might be among the very first human professions to be comprehensively and physically replaced on a massive scale, precisely because they are less protected by the slow-moving and complex machinery of human governance and social systems.
If you liked what you heard today, don't forget to subscribe. I got a whole lot of knowledge to drop on y'all.